Imagine meeting a 46-year-old man whose liver thinks it is 26, whose skin thinks it is 24, and whose ego occasionally behaves as if it has already unlocked immortality. A man who wakes up each morning not wondering what to eat or what to wear, but whether his mitochondria performed well during the night. His name is Bryan Johnson, and his biology is doing something it should not be doing. The numbers bend. The charts look confused. The doctors checking his blood work have the expression of people who expected a normal report and instead found the plot twist of a sci-fi film. Most humans age like old laptops. Every year the battery drains faster, the fan gets louder, and the processor warms up just by opening an email. Bryan somehow has managed to run the opposite script. It is as if someone put him on ultra-low power mode, cleaned the dust out of his circuits, and installed a better operating system without asking for permission. And here is the reason. Bryan is not famous because he is rich or eccentric. He is famous because he made a bet so bold it sounds like something two sleep-deprived scientists would whisper about at 3 in the morning. He believes aging is a solvable problem, not a destiny, not a slow collapse. A bug in the code of life that you can debug if you measure enough, track enough, correct enough. That idea became Blueprint, the project that turned him into the most monitored human on Earth. Every calorie calculated, every organ scanned, every biological process optimized, like he is trying to run his body the way NASA runs a spacecraft. He is the man who looked at mortality and said, "What if I just do not accept that?" Most people try to live longer by exercising a bit more or eating a little better. Bryan turned his existence into a full-scale engineering experiment with a single purpose: slow aging, reverse it if possible, beat the biological curve before it beats him. He is not trying to feel younger. He is trying to prove that aging itself can be pushed back if you attack it with enough discipline and enough data. And the strangest part is that his numbers suggest he might be onto something. His inflammation is low. His cardiovascular markers are stable. His epigenetic age is dramatically younger than his real one. Something in his system is genuinely slowing down. But before we go further, here is the science you need. Your biological age is not the number on your passport. It is how old your cells behave. It is calculated through blood markers, inflammatory signals, epigenetic clocks, and a few tests so expensive they make you reconsider your career choices. Most people measure older than their real age. Some match it. Bryan measures dramatically younger. This does not make him immortal. It makes him statistically unusual, medically fascinating, and scientifically worth watching very closely. So the real question becomes simple and unsettling. If these numbers are real, how long could this man actually live? Because a 46-year-old with the biomarkers of someone 20 years younger is not just an anomaly. He is a glitch in the human pattern. To understand how he reached this point, you need to know the man he was before he became a living laboratory. Bryan was a classic Silicon Valley success story. He built a company. He sold it. He made more money than most people will ever see unless they marry incredibly well. Then came the collapse. Depression. Isolation. A body that stopped cooperating. And during that fall, he realized something brutally simple. Success meant nothing if his biology was breaking beneath him. That moment shattered him, but it also rebooted him. So he rebuilt himself, cell by cell, organ by organ, marker by marker. Blueprint was not born out of vanity, but out of panic and precision. A desperate man turning himself into a scientific mission. And here is why you are here. We are not going to promise immortality. We are not going to repeat Silicon Valley fairy tales. We are going to estimate, realistically and scientifically, how long Bryan Johnson can actually live if his numbers continue to evolve the way they do today. Before we continue, a quick note. You are watching crazy science stories where real science gets weird fast. If you enjoy this kind of journey, subscribe. It will not extend your life, but it will keep your curiosity awake. And tell us in the comments which crazy science story you want next. Your idea might shape the next episode. Let's go back to Bryan Johnson. To understand how long he can live, you first need to understand how he managed to hack his own biology. And that story begins now. If Blueprint were a book, it would not look like a self-help guide. It would look like the instruction manual for operating a prototype organism that tries very hard to pretend it is human. Bryan is that organism. He doesn't wake up. He boots. His morning begins with diagnostics. Heart rate, sleep depth, glucose curves, oxygen saturation. He checks himself the way an engineer checks a machine that has been running all night. Light therapy comes next to align his circadian rhythm. A controlled breathing sequence follows. Then a first wave of supplements designed to prime his metabolism. His body is treated like a device that needs calibration before it can do anything meaningful. Breakfast arrives, although breakfast is a generous word. It is closer to a nutrient equation. A precise blend of plants, oils and proteins arranged with the emotional warmth of a spreadsheet, but the metabolic efficiency of a finely tuned engine. It has no culinary ambition. It exists to make mitochondria smile. His exercise follows the same philosophy: strength training to protect muscle mass, cardio to support heart efficiency, intervals to keep energy pathways flexible, no improvisation, no random enthusiasm. His workouts look as if a panel of biologists with trust issues designed them. Then come the extremes. An infrared sauna hot enough to make metal reconsider its future. A cold plunge that could intimidate a polar explorer. Full body red light sessions where he glows like a futuristic lighthouse. Electromagnetic recovery devices that hum like distant storms. His life sometimes resembles a laboratory designed by an optimist with a high tolerance for discomfort. And then comes the controversial part. Bryan once tried a plasma transfusion from his teenage son. The experiment was brief, the benefits uncertain, and he abandoned it quickly. But the story remained because it reveals something essential. He is willing to test every lever of human biology, even those that make the public raise an eyebrow and whisper that this man is taking science very seriously. Beyond that, he uses injections and targeted treatments that push him toward the frontier of rejuvenation research. Growth factors for tissue repair, laser-based techniques to stimulate regenerative pathways, plasma-based interventions to support cellular turnover. Some experts applaud, others cringe. Bryan simply watches the data and adjusts. Then comes the genetic frontier. He does not edit his DNA or rewrite chromosomes, but he uses peptides and biochemical signals that influence how his genes behave. Molecules that speak to longevity pathways, activate repair systems, and nudge cells toward a younger expression pattern. It is not gene editing. It is gene whispering. Subtle, temporary, experimental. His supplement routine is its own universe. more than 200 compounds across the day. Vitamins, minerals, antioxidants, cofactors, amino acids and molecules with names that sound like secret access codes. People say he takes more pills than their grandparents. The truth is that he probably takes more than several grandparents combined. But Blueprint's true core is the testing. Relentless testing. Unforgiving testing. Bryan gives more blood than a vampire on a yearly contract. He undergoes full-body MRIs, ultrasounds, retinal imaging, coronary scans, dental scans, microbiome sequencing, hormone mapping, and vascular analysis. There are laboratories that know him more intimately than some of his friends. And the results are real. His inflammation remains low. His glucose curve barely moves. His cardiovascular system behaves with quiet discipline. His sleep cycles run like a metronome. His liver appears to have renounced the concept of stress altogether. His epigenetic age moves at half speed, and some biological markers even reverse. Blueprint is not magic, it is math. Aggressive, obsessive, and beautifully engineered math. But even with this precision, one truth does not move. Biology still has a ceiling. Cells misfire. DNA cracks. Mitochondria stumble. No routine, however perfect, can erase every microscopic flaw. Blueprint can slow the clock. It can soften the damage. It can push the body farther than most of us ever will. But it cannot remove the hard limit built into human biology. And that takes us directly to the next part of the story. The place where even Bryan Johnson must stop. Before we estimate how long Bryan Johnson can live, we need to face the part of the story that no amount of optimism can erase. Biology comes with rules, not suggestions, rules. And some of these rules behave like unbreakable laws carved into the architecture of life itself. Let us start with the simple truth. We age because the body is a machine that slowly wears out. The problem is that it is the kind of machine that costs a fortune, cannot be replaced, and does not come with a warranty. If anything breaks, you are the one who pays. There are 4 main villains in this story. First, DNA damage. Every day, thousands of tiny errors appear in your cells. Radiation, metabolism, stress, even normal breathing. Little cracks appear in the genetic code. The body repairs most of them, but not all. Over time, the errors accumulate, like typos in a book that slowly becomes unreadable. Second, telomeres. These are the protective caps at the ends of your chromosomes. Imagine shoelaces that fray every time you tie them. Each cell division shortens them a bit more. Eventually they get too short, and the cell refuses to divide. This is cellular retirement, except nobody throws a party. Third, the immune system. When you are young, your immune cells are elite soldiers. As you age, they become tired, forgetful, and slightly confused. They attack the wrong targets, miss the right ones, and eventually behave like security guards who keep losing their keys. Fourth, cellular errors. Proteins fold incorrectly. Mitochondria lose efficiency. Hormones drift. Repair systems slow down. Imagine a factory where the workers get old, the machines break, and the manager is on vacation. This is the great irony of life. You are born as a perfect biological symphony, and you die as an orchestra, desperately out of tune. Now, here is where things get interesting. A tiny group of humans, known as supercentenarians, manage to reach 110 or even 120 years. They do not do it with supplements or advanced routines. They do it because their biology has an unusual talent for repairing damage and controlling inflammation. Their DNA stays stable longer. Their immune systems age more slowly. Their inflammation levels stay remarkably low. And their cells divide with fewer errors. They are outliers. Biological anomalies. The closest thing nature produces to long-lived prototypes. So the question becomes obvious. With blueprint and technology, can Bryan join this ultra-exclusive club? Can he become one of the rare humans who actually reach the highest limit of natural lifespan? The honest answer is yes, but only up to a point. Blueprint gives him a massive advantage. It slows inflammation. It stabilizes glucose. It protects mitochondria. It keeps his biological age low. It makes him more similar to a supercentenarian in his 40s than to an average human. But there is a limit he cannot cross alone. Because even if he slows the damage, he cannot erase it. Aging is not a race you can outrun indefinitely. It is a clock that keeps ticking, even when you treat your body like a scientific instrument. And that brings us to the turning point. If Bryan wants to go beyond the natural limit of human life, he will need something much bigger than discipline and vegetables. He will need technology powerful enough to rewrite the rules of biology itself. And that revolution might already be on the horizon. Up to this point, Bryan Johnson is winning the battle against biology the old-fashioned way. Discipline, measurement, optimization. A lifestyle so strict it makes Olympic athletes look disorganized. But beating aging entirely is not a lifestyle problem. It is a technology problem. If Bryan wants to live far beyond the natural limit of human life, he will not do it with smoothies and meditation. He will need a new generation of tools. Tools powerful enough to rewrite the very software of the human body. The first one is cellular reprogramming. Scientists have discovered that a set of molecules can rewind cells to a younger state. Not metaphorically, literally. They take an old cell, play a kind of molecular lullaby, and the cell wakes up, thinking it is 20 years younger. Some labs have reversed age markers in mice by as much as 80%. It is the closest thing we have to pressing a biological reset button. The second is gene therapy. If aging is a story written in DNA, then gene therapy is the pen. Imagine correcting genetic errors, upgrading immune cells, enhancing repair mechanisms. It is the body version 2.0 without the traditional bugs that ship with the factory model. Third, lab-grown organs. Right now, scientists can grow mini livers, mini brains, mini kidneys. They are small, imperfect, but they work. In a few decades, a 46-year-old Bryan could order a new liver the way some people order new batteries. If one organ gets tired, you replace it. The body becomes a serviceable machine instead of a disposable one. Fourth, nano repair. This one sounds like science fiction, but it is already being explored. Tiny particles that travel through the bloodstream, repairing microscopic damage, unclogging vessels, cleaning up cellular trash. A maintenance crew so small it could sail through your capillaries like tourists in Venice. Fifth, predictive diagnostics. Algorithms that detect diseases years before symptoms appear. Cancer in its first cell, Alzheimer's in its first glitch, heart disease in its first microscopic crack. The idea is simple. If you stop every catastrophe before it begins, you never get old in the catastrophic way humans usually do. Now here is the important part. These technologies exist on a timeline, and that timeline matters more than anything else for Bryan Johnson. Cellular reprogramming in humans is still early, but progress is accelerating. Gene therapy is already saving lives. Lab organs could be mainstream within 20 to 30 years. Nano repair may take longer, but it is not fantasy. And diagnostics are improving every year. The question becomes brutally simple. Will these breakthroughs arrive early enough for Bryan to use them? Will the science outrun his aging? If everything goes well, Bryan enters the future with a 20-year advantage. His biological youth gives him more time than most of us to reach the next wave of medicine. But even then, technology is not guaranteed. Research can fail. Projects can collapse. Breakthroughs can stall for decades. And even if the technology arrives on time, one final enemy remains. An enemy that does not care about discipline, smoothies, supplements, or futuristic therapies. Randomness. The biological accident. The mutation that appears out of nowhere. The silent infection, the unexpected stroke. The chaotic moment where nature reminds us that it is still in charge. And that is why the story does not end here. Because before we give a number, before we draw a line on the timeline, we need to confront the last part of the puzzle. What is Bryan Johnson's real life expectancy? And what does the data actually predict? Now that we have walked through the numbers, the biology and the technology, it is time to answer the only question that really matters. How long can Bryan Johnson actually live? Not theoretically, not philosophically, scientifically. And to answer that, we need 4 possible timelines. The first one is the low scenario. It is the one nobody wants, but biology always keeps on the table. If Bryan suddenly stopped Blueprint, or if a major setback hit him out of nowhere, he would fall back into the regular curve of human aging. This does not mean disaster. It means he would return to the mortality slope of an ordinary 46-year-old. In this case, his lifespan would land between 75 and 85 years. Not tragic, not miraculous, normal. The second scenario is the realistic one. Bryan continues Blueprint exactly as he does now. He tracks his inflammation. He stabilizes his glucose. He monitors his sleep cycles. He treats his organs like VIP guests. Under this scenario, the science is surprisingly clear. Low inflammation, strong muscles, stable cardiovascular markers, and a biological age that stays young all combine to put him far above the usual curve. Here, Bryan could expect to live between 105 and 115 years. This is not science fiction. This is statistical probability based on his current biomarkers. In simple terms, he has built himself a body with the maintenance schedule of a luxury spaceship. He will almost certainly live longer than most humans alive today. The third scenario is the optimized one. Blueprint continues, but Bryan also gains access to moderate longevity breakthroughs. Not miracles, not immortality, just incremental upgrades, better diagnostics, improved gene therapies, early organ replacements, stronger rejuvenation techniques that arrive before his cells hit the hard limit. In this scenario, the probability stretched to 120 or even 130 years. It is still within the biological limit of our species, but near the very edge. A place only a handful of people have ever reached naturally. If Bryan lands here, he becomes one of the longest-lived humans in recorded history. And then there is the fourth scenario, the extreme one. The one that sounds like the plot of a documentary we have not made yet. If cellular reprogramming becomes safe for humans, if we learn to rewind biological age at scale, If gene repair becomes routine and organ replacement becomes trivial, then the ceiling breaks. Under that scenario, Bryan could live to 140 or even 150 years. At that point, he will need to find a retirement home that accepts immortals, which may require its own technological revolution. Now here is the part where the math meets reality. The low scenario is unlikely but never impossible. Biology does not care about your spreadsheets. The realistic scenario is the most probable. The optimized scenario is genuinely achievable if technology keeps progressing. And the extreme scenario depends on breakthroughs that are already being explored in labs right now. But lifespan is only half of the story. Living long is not the same as living well. And if Bryan Johnson does manage to stretch his life far beyond the rest of us, another question begins to rise. A question much stranger than aging. A question we have avoided until now. If he gains all this extra time, what does he do with it? When you look past the blood tests, the routines, and the futuristic graphs, you find something simple. A man who refuses to sit still while time approaches. Bryan Johnson treats aging like a problem to solve rather than a fate to accept. He reflects our era more than he admits. We fear getting old, we chase shortcuts, we hope for miracles, yet many people treat their bodies like rental cars someone else will eventually pay for. Bryan chose another path. He treated his health as a mission, and even if his methods are extreme, he showed up every day and did the hard work that most people postpone until life forces them to change. There is something worth learning here. Taking care of yourself works. Moving your body, eating real food, sleeping well, lowering stress, and building habits that last. You do not need 200 supplements. You need consistency. Small actions repeated often. They build the future version of yourself that you will be grateful for. Now for the truth. Bryan Johnson will not be immortal. Biology does not bend that far. Randomness still rules part of the game. But with his current numbers and his discipline, he can realistically reach 110 years. With solid scientific progress, he might reach 120 or 130. Beyond that point, his lifespan will depend on future discoveries more than on anything he does today. He can outrun parts of aging, but no one outruns chance forever. And maybe that is the real point. This experiment is not only about how long he can live, it is about how far he can stretch the idea of what a human life can become. It is about exploring the time we have with more intention and less negligence. Your body is the first scientific experiment you ever conduct. It deserves care long before it demands rescue. And every small choice you make today writes a line of the future you will meet tomorrow. So now the question comes to you. How long do you think Bryan can live? 1 century, 120 years, 150? Or does human biology have a hard stop no matter what we do? Tell us in the comments. Time will decide the rest.